Hi everyone, my name is Nazar. I'm a backend developer at Lisk, and today we are going to explore the hands-on development of Lisk SDK 5.1, and we will be covering several topics today. So we will be developing a use case completely from scratch using the bootstrapping features that Ishan just explained, and we will be covering the steps how to implement the business logic inside it, and then how we can test the blockchain, and afterwards some CLI tools, and then last but not the least the UI, which is very important for any application. So I will be covering all those points today, but in a hands-on demo, and for further we can explore like what use case we are going to develop. So this is a use case called Lisk name service, which is inspired from Ethereum name service, and the steps that or the features that we are going to develop today is we are going to develop an application where we can register a .lsk top-level domains, and we can update the records of it. We can resolve domain to any account address, and as you guys have used Ethereum name service, we are going to use Lisk name service domain names to send tokens around instead of using the address. And yeah, that's all. And now let's dive into the code. Let me zoom in for you guys a bit. Hope you guys can see it. So the first dependency that you need for setting up is the Node.js. Apart from the Lisk SDK 4.0, there is no other dependency like Postgres or anything else. So you just need a Node.js. So let me verify if we have the Node.js. So we have Node 12, which is the required version for development. You can try Node 14. It works, but we have tested it more thoroughly using the Node 12. The next thing that you need is this tool that Ishan explained, is Lisk Commander. It's a command line utility for Lisk, and we have this command here. You can simply use this command to install this Lisk utility globally, and once you will install it, you will have this utility installed. Since I already have it, so Lisk Commander 5.1.0, I have it exactly what was published yesterday. So let me create another app for our folder for our demo today. So I'm creating a folder, and then I'm going to use the Lisk init command. So it's going to ask me the application name and then some description of the application, some licensing, and afterwards it's just installing the packages that was just created. And meanwhile, when it is installing these packages, let me explore another thing with you guys. So if you go to the Lisk documentation, there is a section called references, and under references there is a section called schema. And this is a very important topic for if you want to develop the application on Lisk SDK. So you need to understand what are the schemas, how they can be written, how they are defined. So more simply, these are just JSON schema format inspired by the JSON schema, but with some different changes, that instead of the type, we are using data type for serialization, and we have an extra keyword called field number. So you can define the full schema of any object which you can use inside the Lisk ecosystem, and this schema will help to serialize this JSON data into the binary data, and that binary data can be manipulated and then transferred over the wire among the network. Let's check if our packages are completed. Yeah, our packages are completed now. And if you notice here, we also have created a Genesis block and some configuration while we were creating it. And let me open this up. So here is the folder that we just opened up, or it was bootstrapped. And the major thing, it is just a simple NPM package which comes with a package JSON. As you guys can see, it's a tsconfig file, means it is pre-configured with the TypeScript as well. And this package JSON has a lot of things in it that I'm going to explain later. But this is a complete ready to go npm package. And now I can open my terminal so I can show you guys the code as well as the terminal together. So we have it here. One thing I'm going to explain further is that this skeleton inside the application, you guys see app, commands, these are the skeletons that are inspired by a template. And if I go and I think something is cutting, I can resize it for you guys. Yeah, it's better now. So if I show you guys with the help command, so Lisk init have this particular flag called template, and this template is used to actually bootstrap the application skeleton. And by default, it shipped with the Lisk TS template, which enforce this directory structure and all other things. And I'm hopeful that in the future, the community will publish more templates for a different application structure. For example, if you want to create some stable coin that comes with a different ready-to-use code, then you guys, our community, can create a different template and they can publish, and you can use that template using this template flag while creating this application skeleton. So this application we have right now is in front of us. Let's explore some of the main directories inside it. So the first and most important directory is this configuration, and if we open it, we have a configuration file, we have a Genesis block, and this Genesis block has a predefined set of initial delegates, some accounts, and a lot of other things that we can explore later in some time. In the configurations, so in particular relation to the Lisk SDK 5.1, I think this configuration is the most important for you guys. We introduce RPC with the IPC and WebSocket support, and if you want to configure, then you can use this. And there are a lot of other configurations which you can change or use. But one thing you should remember is this Genesis config. If you want to create some network, then use this or modify this Genesis config once before starting this network. Once the network is started, then you cannot change this Genesis config afterwards. Otherwise, it will fail on other nodes if they are not changing it. So we have this configuration, and then let's explore what is inside the source. Inside the source, we have apps, and then we have commands directory. Since this application is a complete CLI application, you can use the CLI, and so it has all those commands. And if I can show you guys what commands are available, so if I simply run this bin run in this current directory, you guys can see these commands are available for your application. So it is not from the SDK. Now this application is your application, and it ships with a lot of commands. You want to keep those commands, you want to modify those commands, you can do it very easily. Right now, they're just exporting it. So if I don't want an account create command, I can delete it. If I want another command, I can add it. And inside the app, we have modules and plugins directory. And inside plugins directory, I will explain further. And since we are working on, first, let's start this application and see how it goes. So it says that something is already running on it, and I can close the first application which was running here. So this application is ready and started. You can see there is a lot of configuration in the logs that you can see, but what important for now is to observe that this blockchain is started. It is now forging the blocks as well. It has forged so far the 2 blocks and the third block, and the block height or the block time that we are going to use is from the configuration. This Genesis block configuration defined this block time as a 10 seconds. So after every 10 seconds, new block will be forged. So this was a default application. It comes with all the built-in modules or default modules. And if we want to explore which modules are there, I can open a new terminal here. And just for your reference, I can open a Genesis block. And one more important thing we should cover, this is a secrets folder which was created. You should never check this out in the version control. This secret folder contains all of the passphrases and the addresses of the accounts which are in the Genesis block. So this is just for a development use case. You should not do this in the production, but in the development you need to have some accounts which you can test or use. So we have this secrets file with the accounts, and I'm going to use this account address, and I'm going to use this account command, giving him the address, and yep. Okay, so this application is running, and the error we just noticed is saying that he's saying that IPC socket is not running, and because we had not enabled it, so we can just enable it API IPC flag, and it will start the IPC communication, and afterwards we can run all the commands and they will be working fine. So we have one account, and with the prettify you can read them. These are the account state. For this particular address you have these balances or sequence and nonce. Just to remember, these are like first level keys in the account state refers to any module. So it means there must be a token module registered, there is a sequence module or the keys module and depos. So if we are going to register another module, that module can contain first level key for this account state onward, but it is not required. Any module cannot have account state as well. It's up to you if you want to create or not. So let's stop this application for now, and we need to create our first module which will be implementing the Lisk name service, and for that we can use the Lisk command again, and with the generate module and LNS and 1000. So here the Lisk generate module is the command to actually generate this module, and LNS is the name of the module, and the 1000 is the module ID. We need to use 1000 because first 999 module IDs are reserved for the default modules that will ship with the SDK. So let's generate the first module. Interestingly, so it shows us that it is generating two files. One file is this particular module file. Let's explore this file. And the other thing, it also created some skeleton for the test as well. So we can show this test skeleton as well. It is just a skeleton. If you're gonna implement or add this implementation yourself, you can do it. One other thing that it just did was registering the module. So this module is not just created, this module is also registered with the application. So if I open this modules file, I can see this LNS module was imported, and it was also registered with the application as well. And now it's time to explore the module itself. So this is the module file, and I'm gonna collapse the whole thing for you guys. So this module has very basic structure. So one is this name that we defined on the bootstrapping. This ID is what we defined on the bootstrapping. Apart from that, we have actions, reducers, and transaction assets. And these are the hooks which Miswaki discussed in his presentation. So we can implement these hooks. Right now, there is no implementation, but whatever you want to do, you can do it. And afterward, your module will be ready. There is one important thing that you need to implement by yourself right now is the account state. So does this Lisk name service module is going to have some account state or not? If it is going to have some account state, then we are going to define this account schema for us. And this account schema will be declaring or specifying what kind of properties this module is going to have inside the account state. And for this schema, this is the document that I referred earlier. You should read it very carefully. This is very important because this schema will be used everywhere in the account serialization. So your schema must be valid and the way you want to do it. But since we are in the TypeScript, so I can use the help from the TypeScript to first understand what kind of properties this account state is going to have for us. So let's say I'm going to say LNS account properties or props, and the first thing is going to have this LNS top level key. So if you guys notice that when I run this command earlier, so this account state had top level keys, token, sequence, and keys. So this when we introduce this module, LNS account properties will have this LNS top level keys, and then we are going to define which properties this module actually have. And since we are developing this Lisk name service, and this is going to have some nodes, or you can say top own domains, this account, which domains this account have. So I'm going to use the name for now, own nodes. And this type will be buffer, and it's an array of buffer. It will tell us that this account has these domains which are specified with the hash of the array of buffers. You can have more than one domains, definitely. So why this is an array. And then we are going to use the reverse lookup attribute, and it is going to be another buffer. So the reverse lookup will say if someone finds your address, then to which name your address is going to resolve. And for that, we are going to hash of the node, which is looking like, which is saving all these attributes for us. So these are the two attributes which this account state is going to have. And now, since we have these attributes in front of us, I can split the windows for you guys for reference. And hope you guys can see the code very well. Okay, so now we are going to write the schema, and since using the TypeScript, it will help us to write the schema quickly, or more preferably. So I'm going to define, first of all, the name or the ID of the schema. Since these schemas are reused in the application everywhere and cached, so this ID must be unique around the application. So you should use some better name, LNS account. And then we are going to define the top type of the schema. It must be an object. And then we are going to define the properties. So the first property, as we can see in this type, is this reverse lookup. So this account state is going to have a reverse lookup property. And this reverse lookup property will be field number at 1. It will be the first field. The data type of this field is the bytes. As we can see in the TypeScript, it's a buffer. So when serialized, it will have a data type with the bytes. And the other one, we have this own nodes. And interestingly, own nodes is an array. So we can say it's a type of array, and we can say the items will be of data type bytes. And this is going to have the field number 2. So if you guys read this schema document, you will have more clear in understanding what are the field numbers and what other data types are available. So considering this TypeScript type that I defined, there is this relevant schema we have, and we are going to specify which are the required fields for it. So we're going to do this reverse lookup and own nodes. So we recommend that if something is in the account state, it must be required. There should not be any optional thing in the account state, so that it should be consistent across all the nodes. And we also need to define the default values for these types, or once a new account is created, what will be the default value. So I'd say the for reverse lookup will be the empty, and on nors will also be an empty array. So once the account is created, we will have this. So we just created this account schema and then this relevant account type that helps both to understand it. So once we have this account registered, so logically we need to create a new Genesis block, because so if you guys notice on this Genesis block, so in this Genesis block, you can see there is a hard-coded account state. So all the state of the account, which could be possibly part of the blockchain, is hard-coded into the Genesis block. So once we modified this state and we said that there will be an additional account state available, which for the LNS module, then we need to create a new Genesis block as well, which will have this LNS state for all the accounts like this. So on nors will be empty array, and reverse lookup will be the serialized value for an empty buffer is empty string. So you have to do it for all the accounts, but for now I'm skipping this part, and we will do it later. So we have this account ready, LNS module ready, and this LNS module, we also defined the whole account state that this module can contain. And the next thing is the state transition. So all the accounts which will be created will have this default module. So the question is how this state is going to transition, and for that we need to define some assets. Assets are the atomic computation which can do the state transition. For now, these are only part of the transaction in SDK 5.0, but in the later ones, when interportability module will be implemented, these assets will also be part of the cross-chain messages as well. So considering that, we are going to create another asset for here. So I again use this Lisk generate command, and I'm going to generate the asset. And the first thing I could see the help, and So it is asking to provide a module name, then the asset name and the asset ID, so we can do that. So LNS was the module name. Let's say we want to register. We want to have an asset which name is registered, but this asset will actually gonna register a domain name for particular account. So we have an asset ID 0. Asset IDs can start with the 0 and then go on. But for one module, all the assets belonging to one module must have a unique IDs. So it just created a few files for us. This is the register asset and the register asset spec. And if you guys can see, this spec has some implementation as well. We go to the testing part later on, but now I have to go to this register asset class, and we can see that there is an asset class which is inspired from the base asset. It has this register name and then ID, then it has some schema which is now empty, and then we have this validation and all other things here. And one more important thing is that this register asset has now been imported here on this line, and yeah, on this line we imported this registered asset, and we also have made it part of the transaction assets. So how many transaction assets you have for a particular module, you have to create them and then create an instance of those assets and register them into the module. So that's all. Let's go to this asset implementation. And again, here comes this part which we say we need to define a schema for it. And yeah. Again, I'm going to use the TypeScript to first define a type, because that can give us a clear understanding what the schema should be. And the schema for an asset is the transaction asset. So what attributes someone will provide you when they will send you this transaction. So let me create a transfer asset props. And I say it will be giving me register for number of years. So how many number of years you want to register, name of the domain that you want to register, and then we also take a TTL value, which is very common among the domain names, which is time to live. So this will also be a number. So if someone is going to provide me this transaction, he must provide me this these three fields. And now we need to define the schema related to these three fields. And I'm going to do it very quickly for you guys. So the data type of this field will be, since it's a number, so we can consider it's unsigned in 32. And the field number for this one is 1. And the next attribute we have is this name. And the data type for this name is the string. The field number is 2. And then TTL value, and this TTL value is unsigned in 32, and the field number is 3. Just to highlight here, once you have assigned some field number and once you have some transactions in your blockchain, then you cannot change these field numbers ever. So be careful. You can add more field numbers afterward if you want, but changing a field number of an existing attribute will violate the data consistency across the blockchain, so it will fail. So we have this register for, these are also required, these are also required, these are also required. And we can define the default types for it, but for now I'm leaving it. And since we have this transfer transaction asset, we can use this as a generic prop for the TypeScript. So it will come everywhere here, and I can use it here as well. So the next thing we're going to use is this implementation, how we are going to implement it. And for that part, you have here a complete control of using anything possible in JavaScript, whatever you want to do, so you can use it. So once we receive an asset, it will have this asset object. That asset object will have these three properties here, which we just said, register for, name, and TTL. So let's say we say if asset TTL is less than 1 hour, so it's in TTL is in the seconds, and I say if TTL is less than 1 hour, then we want to throw. So this is not a valid transaction. So we are going to throw this new error, TTL must be 1 hour, more than 1 hour. So this is how simple it is for implementing the validation logic for the blockchain. And whatever logic you want to implement, you can do it here the way you want. And afterward, the point is, once you have a valid transaction, then you want to create, apply this transaction to the blockchain. Where it comes the important part, we have this state store. Just assume for now that I have a function called, let's say, asset is equal to create domain. I have a function which takes my asset and create a domain object for me, and then I'm gonna get the account, const the sender account, and let's say store.account. We want to get whoever sent this transaction to us. So whoever sent this transaction to us, we got this account, and then we say that account dot, I want to update this account for this account is going to have this account properties, which we simply declared here. So this account is going to have these properties. So we are going to use this account dot LNS, and whatever you want to modify or on north or whatever value you want to define here. So you can implement any logic you want to do here. And I will show you the whole implemented logic afterward. But one thing I want to highlight here. Let me open this Ethereum name service. So this is the EIP specified by the Ethereum, and this Ethereum name service specify an algorithm called name hash algorithm. And this name hash algorithm is used to actually hash all the domain names in a consistent and a fixed buffer. And they specified it somewhere like all the logic in it. And here they explained further, and the algorithm for the hashing that use is specified by KeyCalc 256. And the point I was highlighting it here that since we are in the JavaScript ecosystem, we are in the Node ecosystem, all of this code that we are working on here is a plain Node JavaScript code. So you can use any NPM package out there. So this is a package out there, Ethereum name service name hash. It has this implementation of the algorithm specified here. So I don't need to reinvent the wheel for us. I can use any package available in the community, and I can make it part of our own blockchain. And yeah, let's go further and do it quickly. Now I'm gonna switch back to the full implementation of this transaction, and we'll explain you guys how I did it. Yep. So we have this application already implemented. I have this LNS module here. And now it have this register asset transaction, reverse lookup asset transaction, and update record asset transaction. It have this account schema defined, and then if I go to the asset, it has all these assets implementation as well. So for the validation, I have mentioned at TTL, register for, and then different logic, how to apply these domains, how to create this LNS object. And if we go and look into this object, you will notice that I'm using this Ethereum name service package here. And this Ethereum name service package is gonna help me out to implement this KeyCalc 526 hash. Yeah. So let's go and look on the test for now. So we have this implemented logic allwhere, and seems my battery is running out. Can someone help me to plug the battery? So meanwhile, I get some power plug for my laptop. Let's explore some of the tests here. Dankeschön. Now we are all safe. So we are going to implement, this is the register asset, and let me open the asset and the test on sideways that we can understand. So here we have this validation logic, and now we want to test this validation logic if this is correct or not. So we have this unit test for it, and in this unit test, we have this using this utility called create validate asset context. This utility will help you to create this context which was passed to this validate step of this asset and process you all the logic you want. So in here I can show you guys that the first step I have, if the TTL is less than 1 hour, then I'm gonna check if must throw some error, and this create validate asset context help me to do it very quickly. So in this testing utility is a part of this Lisk SDK, so you need to just import it and then use it, and it also help you in other cases. I will explain further. And now here we have this create validate asset context. Let's jump to this apply asset context. So in this apply, we want to really change the state of the blockchain. And for that, we want to create some account, and this testing utility also provide you the mocks for the state store that is used in the blockchain. So you don't have to use a lot of mocking on yourself. So this state store mock will provide you all those. And since our testing utility is like independent of any testing framework, you can use in Mocha or Jest or whatever. So why it does not come along with built-in spies or any kind of mocks on top of it. This is just a mock class. And now, if you're going to use with the Jest, you can use spy with the Jest. If you're going to use the Mocha, you can do it on your own self. Whatever testing framework you prefer, you can use it. But this bootstrap applications come along the Jest integration with all those cases. So what we were doing is that we created this state store mock object that is going to pass by. And then we call this another function called create apply asset context. And this create apply asset context take the state store that we have. So there is no actual blockchain running there. It's just a mocked state store, and then we are applying all those steps on it, and we are verifying an expectation what's going on with our transaction. Is it processing or is it not processing? So we have a lot of test cases covered here. So this was one of the utility that I explained, which is around the unit test. And in the unit test, you don't need to have an actual running blockchain. You just need mocks and fixtures to test it. But in some scenarios, we need to have some of the actual application running on. And in that cases, I can explain one more test to you guys. So here you can see this is an actual application test which called functional or network test, the way you prefer. So it create a default application environment, and this application environment will start a real blockchain, and then you can process anything on top of it. For example, I can show you guys that here, like this is the best test case to explain here. So I created an account phrase. From this account phrase, I created an address, and then I created a new account from that address. I created a new token transfer transaction from that address, and then I sent it to the network. I waited for one block, which is very common. It's a step-by-step. If you read this code, it will look like very easy for you guys. Then I created another NLNS register transaction. I sent this transaction to the network again. I waited for one more block, and afterward I had this expectation, which checks if this name was registered or not. And with this logic, we actually tested all of our implementation in a real blockchain running in the background. And this create default application environment help us to create this application environment where we can run and test these real world use cases. And there is another function which can help you create block processing environment. So it can help you for creating the block, creating the fake block headers and all those. So if you go and read the documentation, you will find a lot of use cases or a lot of utilities available in the testing framework that we exported. And yeah, and you can use them. Since the limitation of the time, I can't give you all of the use cases of those test utilities. So I go to the next step. So next step that I want to explain to you guys, I showed you earlier as well, that this is a complete CLI app. And since it's a CLI app with a set of commands available, that means this CLI need to interact with the application with something, with some way, with some communication channel. So for these things, we in these modules, we have these actions and events and reducers. So we have three things here. One are the actions, reducers, and the events. Events are the one which will be triggered from your module whenever some activity has happened in there. And then we have these actions and reducers. If I open these up, you guys can see that I have some very similar reducers and action set. So actions are 1, 2, 3 actions, and the similar names I have for the reducers. The difference between a reducer and the action is that reducers can only be used within the block processing environment. So consider that you have 5 or 10 modules and you are processing a block. So one module can invoke reducer of any other module and perform some business logic. Whereas actions, they are independent of the block processing. You can invoke them anytime from anywhere using the IPC interface or the WebSocket interface or any other interface you want. And you can use these actions anywhere. So I implemented these 3 actions, and since I have these actions here, so I want to create the relevant commands as well, and I want to show you guys how easy it is. So we are providing you this base IPC command, and this command here is just checking if some address is available, like I want to see if the john.lisk or the do.lisk is available or not. And this is a CLI command. I can simply invoke the client with the action that I have. This action resolve name will trigger the logic defined in here, and it will check if the resolution was done or not, and then it will print out the output. So within, you guys can see within 26 lines of a code, we created a very beautiful CLI command, and you can use it using resolve, like I can show you all the commands here. So you can use it like this. So we have the lookup and the resolve command here, and this is the usage of those commands. Yeah. So the next thing which comes after the CLI is the UI. Once you have a CLI, you are running it locally, but you want to have some web UI for your users, which they can use on their browsers. And now we're going to explore this part as well. And for that, we have a concept called plugins. So plugins is an off-chain logic. So we can create a plugin which can contain this UI. And so I can say Lisk generate plugin, and I can provide this help. Yep. So I can create any plugin which will be containing any logic. Since this UI is not part of the chain, it is an off-chain logic, so we can put them into the plugin. So there are 2 ways to create a plugin. One way is to create inside this directory structure we have, or the other way is to create a standalone plugin. So we recommend if your plugin is contains a lot of UI tools or other things which makes the plugin heavy, or you want to distribute this plugin to the other users who can use them. So you can use a standalone plugin as well. So multiple blockchain can use your plugin. But if you want your plugin to be particularly and only for your blockchain, then you can create them inside your application skeleton, and then it will be available in this plugin directory. But for now, I'm going to have some UI on this LNS, and I created this as a standalone plugin. So I'm going to explore with you guys here. So this is the UI plugin. It contains different things, but one important thing is this dashboard plugin class. This dashboard plugin class will help you to register this plugin with the application environment. This plugin can also have some action events, but we are going to explore those later. And you can load this plugin. In this case, we are just loading up the express and loading this static file there, which will be compiled. And in this UI, we have all the React code that we can do. And in this React code, I can show you a few of the code which I found very important to be used, which is here. So we have this client object, and this client object is created in app.ts, and yeah. So we have this package called Lisk client, and in this Lisk client package, everything which can run on the browser is listed in this Lisk client package. Whether you are using React or any other web tool and you want to run something on the browser, then you can use it. Just call this API client, and then we created this WebSocket client, providing them the URL of the WebSocket where our application is running. Once we have this connected, I can use this API client everywhere. And here I'm giving you an example that I created this client, and then I invoked this LNS lookup address, and this LNS lookup address is gonna invoke the business logic which was defined in this action lookup address inside the module. So this way we can you can like implement or connect the UI with the backend application which is running. And now I'm gonna give you guys a demo of the whole application, and for that we need to start the application. So I need to start with the WebSocket because our UI is using the WebSocket. I'm specifying some particular WebSocket port as well. So my application started running. Here I also have my UI running. So I go here and explore it further. So here is the UI which is like running right now, which provide me all the features of the use cases which we implemented. Let's say, do we have lns.lisk domain available? Yes, this domain is available. We can search any other domain. My name, for example, this name I already reserved, so it is not available. So first thing is that we need to disconnect, and let's say we connect with some account. Then we can register a new domain here. And for registering something, we need some secret account passphrases. So let's say take this passphrase. So we are registering for this account. So I'm going to connect with this account. So it is connected. And let's say we search a name. The name of is D13. Let's say we want to register this name. So we want to register it for 1 year. This is the TTL value. This is the passphrase. Since we are not storing the passphrase in the session, so you have to provide it all the times you want to implement. This is the minimum fee. The minimum fee is listed there, but I mean, since I'm running it locally, there is no other transaction, so I can just specify this fee. I'm going to register. Let's wait for a block confirmation. Once the block is registered, so this transaction will go on eventually. So this dialog is closed. This domain is registered, D13. If we just search again D13, you guys can see this name is reserved. Let's register one other domain name, D13, 15. So we gonna register this as well for the 1 year. I'm passing this minimum fee also. Let's wait for one other block confirmation. So now this account, you guys can see the account address here. This account has these two domains registered, and these are the attributes. So we can update the record, and but we can do this later on somewhere. But for now, I'm explaining you further things. So these domains, two domains are registered, but the point is, once this account has two domains, which domain name is going to resolve as a default domain for this account. And for that, we need to set up this reverse lookup. And this reverse lookup, I assign it to D13. And okay. Okay, and then provide this minimum fee. Wait for this transaction confirmation. Yes, so we just set up the lookup here. So if you notice on the UI, suddenly the name, the address of this account has been replaced by the name. So if I enable this LNS, disable this LNS feature, you guys can see, so everywhere in the UI, you are looking at the addresses. So there are no names, but if I enable this LNS feature, you guys can see the sender names everywhere. Even on the account name, there is a name. And we can use the same logic to like send the funds. So let's say I want to send to some address, but instead of the address, I can type in the name or the domain. I want to send him the one Lisk memo, which is something memo, and this is 1460. And yeah, wait for this confirmation. Yeah, the block is confirmed. You can see the latest transaction here. So d15.lisk has sent some funds to the Nazar.lisk. So there are no addresses, so we are using the domain names everywhere. So this was the whole UI for you guys to explain, like you can explore later. And afterward, once your application is ready, the point comes how you are going to ship this application. So you are running it locally, you have tested it properly. Now you want to set up or distribute it to your application, your users of the application. So we explored earlier that this is a complete standard NPM package. So there is no complexity in understanding or shipping this application out of the ecosystem of the Node.js. So this is a complete NPM package. So you can publish this NPM package on this NPM registry, or if you have any private registry, you can register or publish it there. So here I'm just explaining you guys Lisk core, which is one of our mainnet implementation using the Lisk SDK. So Lisk core is published as a standalone NPM package, and this installation is also simple. You can simply install this application and then start using it the way you want. If we application, so our application name was Lisk name service. So if we publish this application to the NPM registry, then we are gonna simply install this name registry using this command npm install, and then everyone can use this application. Yeah, that's all for the today from my side, and hope you like it. And the code and the code of this demo will be published to our repo Lisk SDK examples by tomorrow. You guys can explore the code there and give feedback. Thank you so much.